This video is on integration using residues. In today's video, we are going to find the poles and the residues of the function f of z is equal to z by z square plus 1. Clearly from the question, what is our f of z given? So f of z is given as z by, this is z square plus 1. So this can be written as f of z can be written as this is z by, this is z square minus I square. So I square value is minus 1. So this is minus of minus plus 1. Clear? So now this is of the form a square minus b square. F of z can be written as this is z by, this is z plus I into z minus I. Clear? Now in order to find the poles, we have to equate the denominator to 0. Now for equating the denominator to 0, clearly z plus I into z minus I is equal to 0. So if I equate z plus I to 0, so z plus I to 0, then z value is equal to minus 1. So which is a simple pole. So this is a simple pole. And now if I equate z minus I to 0, then z is equal to plus I, and which is again a simple pole. So here we got simple poles as plus or minus I. Now the pole values are z is equal to minus 1 and here z is equal to plus 1. Now we have to find the corresponding residue values. So here we have to find the residue values for each and every pole as they are simple. Now see here for residue values, see here residue of f of z for simple pole z is equal to z naught is equal to, this is limit z tends to z naught, z minus z naught into f of z. So in this z naught value I am taking as the pole value, first I am taking as minus 1. Therefore residue of f of z at point z is equal to minus I is equal to limit z tends to z naught value, the pole value I am taking minus 1 and this is z minus. So here already there is minus and this is minus, minus of minus plus 1 into f of z. So our f of z value is nothing but z by. So here this is z by z plus I into this is z minus I. Now if I cancel z plus I from numerator as well as denominator and substitute minus I value in place of z. So here this value will be minus I by, so here in place of z as minus I and this is minus I. Clearly this value is minus I by minus 2I. So if I cancel minus I from the numerator as well as denominator, so if I cancel this one, so the value remains as 2. So this is the residue value of f of z for the point z is equal to minus 1. So clearly for the pole value z is equal to minus 1, our residue value is plus half. And the next one here is our pole value is z is equal to I. For again z is equal to I, here is the formula. For the pole value z is equal to I, the residue of f of z, see here, residue of f of z at point z is equal to z naught is equal to, this is limit z tends to z naught, this value is z minus z naught into f of z. Now if I substitute the same thing here, z naught value as plus I. Now residue of f of z at point z is equal to, see at point z is equal to plus I, see what happens here. So this will be limit z tends to I, z minus I into f of z. So what is the f of z value? F of z value is nothing but z by. So this is z by, this is z plus I into this is z minus I. So if I cancel the numerator as well as denominator and substitute the value of z as plus I, so this will be I by, so in place of z as plus I. So this is I by, this is 2I. So if I cancel this I, the value remains as half. So this is the residue value of f of z at point z is equal to, at the pole value, see here, at the pole value z is equal to I, the residue value is equal to half. So this is how we have to solve, and let me explain you once again. See, first of all we have to find the poles and the residues of the given function. So the given function is as this, and this can be written in the form of a square minus b square, which I have written as a plus b into a minus b. So in order to find the poles, we have to equate the denominator to 0. So after equating each and every term in the denominator to 0, we got the poles as z is equal to minus 1 and z is equal to plus 1, which are simple poles. So first one, we have to find the residue for the pole z is equal to minus 1. So here is the formula. In this formula, after substituting and substituting z as minus I, so we got the value as plus half. And the next one, the next pole value is I, and in this, if I substitute z is equal to I, and if I cancel, see here, this is z minus I and this is z minus I. After cancelling z minus I from the numerator as well as denominator and substituting the z value of I, so after cancelling, I got the residue value is equal to half for the corresponding pole value z is equal to 1. So this is how we have to solve. These are so simple, and if you follow all the videos, it will be very useful for your preparation. And if you really like, what to do, please subscribe and pass it on to your friends.